Hey, my name's Sai, and today we're going to be talking about solving math problems using models. When I say solving by models, I really just mean making visual cues like this to help us solve it. And if you draw a model well, you can almost get to the answer instantly. So it's going to greatly help you. So we're going to be In this chapter, we're going to go over how to use the model drawing to solve problems that involve sums, differences, multiples, and fractions. So basically the four operations. Example 1. So these two people have $80 altogether. The amount of money Joe has is three times the amount of money Jason has. How much does Joe have? So here, what you can do to represent that is make, I guess, um, each different part of that $80 a rectangle. And so Jason just has one of those, and because Joe has three times his money, it's going to be three of those rectangles. So altogether, these are $80. But you see that in total, there's four units of money, I guess. And if you divide 80 by four, it's going to be $20 per each of these rectangles. So if you want to figure out how much money Joe has, all you have to do is multiply how much money each of these rectangles has by the number of rectangles. So in this case, it's going to be 20 times 3. And this is way easier than, like, say, using um, multiple algebraic equations, I guess, to solve it. So um, to solve it, I guess you could say algebraically, you could say Um, so for you could use the letter O to represent Jason's Joe's money, and A to represent Jason. So if you say O plus A equals 80, and 3A equals O, that's going to be a lot harder to solve than just using these models. So you can already see how useful they are. A farmer has 120 mares and stallions altogether. The number of stallions is 20 more than the number of mares. How many stallions does the farmer have? So you can start off by just giving each of those one rectangles and adding 20 to the mares. So if you can see that, you'll just see that if the total is 120, you can subtract the extra 20 mares from that and get 100. And because they both have, when you subtract 20, they both have an equal number of horses. So 100 divided by 2 is 50. And this is another example where writing multiple algebraic equations is much harder than just solving using these models. There are 45 apples in carton A and 55 apples in carton B. How many apples must be transferred from B to A so that the number of apples is three times as many as in carton B? So, 45 apples in carton A, 55 in carton B. So the total is 100. So if there's a total of 100 apples, um, you want to make sure that carton A has three times the amount of apples. So um, you can divide the apples into four groups represented by these rectangles here. And if you do that, carton A has to have three of these rectangles in order to have three times the number of apples, and B just has to have one. And when you do that, you get that you figure out that 25 apples is one of these rectangles. So 4 times 25 is 100. So 30 apples must be transferred from carton A to carton B once you do the math. Let's do another example actually. So Alan, Benny, and Charles have two $40 in total. If Alan gives Benny $20 and Charles gives 15 to Benny, they will each have the same amount of money. How much money does each of them have at first? So again, you can just divide 240 to 3, so each of them must have $80 in the end. If Alan gives Benny $20 and Charles gives 15 to Benny, they will each have the same amount of money. So 20 plus 15 is 35, and that is the amount of money that Benny is short of 80 by. So that means that Benny has $45 at first, and Alan has $20 extra that he gave to Benny, and Charles has $15 extra that he gave to Benny. So that's 20 plus 15 equals 35. And you can really see how well it's represented by these models. That's about it for today.